Throughout the oil and gas industry, focus is turning to economical methods of completing wells that in some cases, due to high completion cost, would not be feasible. One prime example of these types of completions are those in which the tubing is cemented in place without use of a packer. Once this step is complete, the operator must then recomplete by cutting above the cement and rerunning completion strings with all the necessary equipment. This process is not only time-consuming, but is also dependent on the integrity of the cementing portion of the first stage. A more fit-for-purpose completion system for disposable wellbores would include all the equipment necessary to safely and economically complete these wells. This system would also need to be a true monobore one-trip completion, which would allow cement to be pumped offline, freeing up the rig to move to another location on the platform. This completion system would eliminate 18 to 24 hours of rig time, which would offer a considerable cost savings. Components of this one-trip monobore system would also need to function properly following the cementing operation. These capabilities currently exist in the monobore cement-through completion system. This system relies on specifically designed cement-tolerant components that provide safety and the ability to gas lift to again enhance the profitability of the well. To better understand this concept, the following animation will demonstrate the functionality of the system. Once the intermediate string of casing has been set to the desired depth, the open hole section is then drilled to desired total vertical depth. Once drilling is complete, the next step is to run the monotrip completion string. The completion components from bottom up are as follows: float shoe, latch collar, hydraulic set element only packer, hydrostatic closed circulating valve, 4 or 5 cement-through side pocket gas lift mandrels, the cement-safe surface-controlled subsurface safety valve, and a cement wiper plug specifically designed for this application. Once the completion string is run in whole and the tubing hanger secured, the ring can be skidded over on the platform to commence other drilling operations, and the cement is pumped offline. Being able to pump the cement offline frees up the rig for other operations, which will afford the operator considerable savings over the span of several wells. The predetermined volume of cement is then pumped through the entire completion string, filling the annulus to approximately 300 feet above the packer. Once the volume has been pumped, the cement wiper plug is then launched and pumped to the bottom of the completion string, where it will land in the latch collar, forming a seal for the following pressure cycles. Once the wiper plug has latched and sealed, applied pressure to approximately 3,000 psi will set the hydraulic packer. As the packer is set, pressure will be increased to approximately 4,000 psi, at which time the rupture disc in the hydrostatic closed circulating valve will burst, allowing circulation from tubing to annulus, cleaning out the excess cement. Once the annulus is free of excess cement, the annulus side is closed and pressure across the system increased to approximately 4,900 psi, which will shift an external sleeve on the hydrostatic closed circulating valve, regaining tubing to annulus integrity. The internal sealing insert can also be shifted up to the closed position to form a secondary barrier. The Baker Oil Tools Monotrip Cement-Through Completion System offers an economical means to complete wells with short life expectancies or marginal return on investment. By reducing the rig time necessary to complete and adding the ability to perform gas lift operations, these marginal wells can become productive and profitable. For any questions or interest in the Baker Oil Tools Monotrip Cement-Through Completion System, please contact your local Baker Oil Tools representative or visit our website at gasliftsystems.com. We look forward to meeting your completion needs now and in the future.